Hi, my name is SYSZARINNA OMAR from ROF40 System Electronic. Today, I will present about my lab, which is about inverting and non-inverting operational amplifier for my subject analog circuit 2. Okay, firstly, we did the inverting operational amplifier. I already do the calculation here for gain and Vout. So here, RF is given for 4.7K. So I already calculate and we got gain for is negative 4.7 and V out 4.7 voltage. So here this is my circuit, so I will run. Okay, this is the waveform. So if you can see here, the C1 is for V in. So we got negative 998.21 millivolt, which is negative 1. So if you see here, we got for V in 4.69 volt equal to 4.7 that we calculate earlier. So in here, we have to change RF is 10K. So I will change in my circuit for 10K here for RF. And then we will run. Alright, if you see here, this is our V in negative 984.99 millivolt, which is equal negative 1. And if for V out, if you see here, is we get 9.9944 volt equal to 10 volt, like we calculate in here. And if okay for inverting RF 33K, this is the circuit. We already changed the RF, so we run. Okay, if you see here, the graph is clicked. For C in, for V in, the value is still the same, negative 1 millivolt. While for V out, there is only 13 volt in here. So if while we calculate the gain and V out, we have to get negative 33 volt, but we only get 13 volt only. Why the output waveform has been clipped? Okay, output waveform has been clipped because clipping occurs when voltage in gain is smaller. Okay, here if you see that then the voltage source. Here we put 15 volt. We use 15 volt and it's maximum. Okay, after we run, we get the 13 volt in here. Because it's impossible to get the same value with the V source, and it's the maximum voltage for this operational amplifier. Okay, second question. Why is it called an inverting amplifier? Okay, it's called inverting amplifier because in circuit, we use negative voltage. And it will get negative voltage wave. But the output will get positive phase, so it will be invert from negative to positive. Okay, next we will do non-inverting operational amplifier. So here we will have to find the gain and output voltage for V out. So here given RF 4.7 kilo ohm. So I already calculate here and we will get 5.7 and 5.7 volt. So this is the circuit 4.7K. So I run simulation. Okay, this is the waveform. So if you see here, for VE, we should get for around 1 millivolt, and for VR we should get around 5.7 volt. So we already get the closest with the calculated. Okay, for RF 10K, I already calculate also. So again, we will get 11 and we will get 11 volt. So this is the circuit, 10K, so I will run. Alright, this is the waveform. So for VE, we should get around 1. Yes, we get 96.87 millivolts, so it equal to 1. So for VR, we have to get the 10.949 volt, which is 11 volt. So we get the same answer with calculated. And then for 33K, gain and output voltage for 33K. So I already calculate also, and we got the 34 and for VR 34 volt. So here we have to change the value for F, and then we run. Okay, if you see here, we will look at the waveform is clipped. So if you see here, we will get around 1 also for V8, and yeah, 3 because okay because in here we put only 15 volt and it's the maximum, and it's only get 13 volt. It's impossible to get the 33 kilo ohm, so that's the maximum. Only we will get 13 volt in here. Okay, I will answer the question. Why is it called a non-inverting amplifier? Because as you can see, the voltage, the phase when we enter the positive phase, and the output is also in positive phase. So it did not invert any of the phase, so it called a non-inverting amplifier. Okay, what does non-inverting mean? If a sine wave is connected to the operational amplifier, positive terminal. Okay, the non-inverting means that when we insert this sine wave into the non-inverting input, so it becomes a non-inverting amplifier. Because in this condition, the wave will not change thus after it has gone through the amplifier. Okay, for the discussion for this lab is inverting and non-inverting operational amplifier. The step is the same using multisim live online circuit. Calculate the calculation and compare between experiment that we do in multisim. The inverting wave is applied at negative for all ground, and positive is applied at a negative applied at foreground and positive at operational amplifier. While for non-inverting, negative at operational amplifier and positive at ground. The value of RF is also changed, and for 33K ohm, we will get waveform that clip. In conclusion, as a student, we will be able to understand and demonstrate about inverting and non-inverting operational amplifier circuit. We will get to know the difference between them and investigate. Investigate the operational amplifier voltage follower. Okay, that's all from me. Thank you.